example 10 is asking us about the exact values of trigonometric functions. So this is where we have to use those exact answers, no decimals. We want the actual value of it, and that was from our class activity from section 1 where we were looking at those exact values. So the first one is the cosine of negative 675 degrees. Well, we weren't asked to do that. We were never asked to find the exact value of cosine of negative 675. So what we need to do is we need to relate it back to an angle between 0 and 90 degrees, right? We want to find an acute angle like we've been doing this entire section. So we start, at 0, and we kind of move around and try to figure out where this is in relation to other things that we know. Well, negative 675 is pretty big. So we need to try to fit it back somewhere between 0 and 360 degrees. So to find one between 0 and 360 degrees, we need to start adding 360s. So if we start with negative 675 and we add 360, that is going to give us what? So that means that we need to add 300, so that gives us negative 375, and adding 60 means negative 315 degrees. So negative 315 degrees, I can do that. I can also add 360 again. This would give me 45 degrees. So negative 675 and 45 actually work out to give us the exact same values of cosine and sine and tangent and cotangent and all these other angles. So what I'm going to do is I'm going to say, okay, well, 45 degrees, what value does that make? So if I go back and I think, okay, well, what is the cosine of 45? Well, we just showed that the cosine of negative 675 is going to be the same as the cosine of 45. Well, the cosine of 45 is the same thing as the square root of 2 over 2. You may think, okay, well, it's 1 over the square root of 2. They're the same answer. I would prefer this because it's being rationalized, but I know that that's true based on my class activity. I know that special triangles that we were making, that this is the exact value. If you typed it into your calculator, you get 0.7 something, but that's not what we want. We want to work with the exact values when we work on problems later on in our unit. Excuse me. So that's that. So we've got the square root of 2 over 2. That's awesome. So let's look at the cotangent of negative 14 pi over 3. Oh, goodness. So not only are we dealing with radians, again, so radians, remember, they go from 0 to 2 pi and so on. But we're also dealing with the cotangent. So when we get to the right angle, then we're going to have to think about how this cotangent thing works. So we need to find our reference angle before we do anything. So what we're going to do is we are going to move it into this range over here between 0 and 2 pi. So to do that, these angles are going to have the same properties if by adding 2 pi to it, just like adding 360 in the last problem. So I'm going to add 2 pi. Well, to do that, I need my denominator to be 3, and so 2 pi would be 6 of those. So this makes negative 8 pi over 3. I need to add 2 pi over 3 again, so I need to add 6 pi over 3 again to that. That makes negative 2 pi over 3. And then I'm going to add 2 pi again, and so that would make 6 pi over 3 again, so I'm going to get 4 pi over 3. Yikes. So I've got 4 pi over 3, which is an angle that I can find. So 4 pi over 3 is, oops, that is not what I wanted to do. 4 pi over 3 is down over here, right? Because this is pi, and so I'm a little bit over that. I'm pi over 3 over that. And so I'm down to 4 pi over 3. So my first statement that I want to make is, hey, that cotan of negative 14 pi over 3 is the same thing as the cotangent of 4 pi over 3. That's the same thing. Well, cotangent is the same thing as 1 over tangent, right? It's the same thing as x over y. Well, where would the same x over y occur? Well, tangent and cotangent have this very nice property that they are the same on the opposite side of the unit circle. The opposite side. And we're going to get to the unit circle later. I'm sorry I keep referencing it. But see, on this side we've got negative x and negative y. On this side we've got positive x over positive y. They give the same value. This is the same thing as the cotangent of what other angle? Well, how far backwards did I go? Right? How far backwards did I go? Or can I think of it in relation to something else? Well, man, I am not doing well with this. Well, I am on the struggle bus today, guys. But my 4 pi over 3 extends and has the same value of cotan over here. So let's think, how far up from pi did I go, and to get to 4 pi over 3? Well, I moved 1 pi over 3 up. So it gives me the exact same value as pi over 3. Cotangent and tangent, because they rely on x and y, are the same on opposite sides, because whether I have a positive x and a positive y or a negative x and a negative y, I get the same thing, because a negative over negative makes a positive. So I've got this cotangent of pi over 3, which is great. It's fantastic. I've got this value. I'm good to go. So now, what in the heck was the cotangent of a pi over 3? Well, I know that this is the same thing as 1 divided by the tangent of pi over 3. Okay, so that's what cotangent is. It's 1 over whatever the cotangent is. Well, the tangent of pi over 3 is something that I did find. So the tangent of pi over 3 was the same thing as the square root of 3. Which we can then rationalize that as the square root of 3 over 3. That's what cotangent is. That's the exact value. It's not, let's see, what is that? It's not like 0.5 or 0.6 or something like that. It's just square root of 3 over 3. We can figure out exactly what it is. So there's lots of things we did there. We not only adjusted our angle, but then we found one between 0 and 90. But then at the very end, we can plug that in and figure out exactly what it's going to be. So next unit, when we start digging into the unit circle, you can really start to understand how these angles can relate to each other and start to predict, well, oh, this is the same, this is the same, this is the same, or this would be the opposite. So that's the goal that we're trying to get to right now.